like Payroll was like.
All right.
I love these sunglasses so much though. They're cute.
I feel fly.
They're so mean.
I all day. I want to go get my
Well,
aviators.
No, it was
Sorry,
really
Lauren.
funny. We were walking in the streets of Chicago and my dad was wearing the
Like,
and
technically,
then you just ran up to her bag. She's like, and you're
She's
like,
like,
I look good. And she was like, look at me. And we were just like,
black, gray.
He's
White, gray.
Let's go then.
It's so
Herman, did you get black eyes? I need to get your haircut.
I like it.
No, I just want to see.
And also,
You just wanna get it like
still it's better, but it works.
He's gotta go play poker later.
Exactly.
Like, I needed a
I
haircut.
tried mohawking my ears, my hair yesterday. Yeah,
Are you taking your
Have you, do you ever think you cut it off?
Well, it's like when we like this.
Cause what?
I have a day where I have nothing to
I
do.
just wanna like the really
After school, nothing to do.
It's not like.
First time in so many years.
It's like first.
They're only kind of a lot of
Your face is
And then like, when I did
Yeah,
I decided like you know, like,
Yours doesn't
hold
look
up
like
my
this.
yeah, imagine like keep it, it's longer.
Yeah.
A little bit, like I
spray
have
the top.
Really
Saturday, I
and then
love
there's
you.
scalp.
So.
Yes.
I hurt myself again.
I like
Uh,
it.
Still stay or
Still, sometimes it's really embarrassing. You're standing there just like hot. Your eyebrows touching.
I hate that. Oh my gosh, the other day.
It's like first really learning about the detective thing.
Yeah.
So it's just like playing about I usually use
like
these ones.
really
I still hurt myself. I hate that. Remember it's like right under your
That makes
That is
sense.
a Facebook status right there.
How's that funny? If the glove they gave you doesn't work, why don't you
Mine
use the other one?
Right now.
If you see the video, then you're all burning hair.
Yeah.
Oh, yeah.
I put some more like, well, I want to change.
I'm sure that they
Change your guy.
I knew all those people I forgot every weekend.
I love your shoes.
That's like the worst. You're like, oh my gosh, stop.
And then you put your hair in a wand.
Is that
I
SAD?
don't think
Yeah, I'm sorry, you went.
I used to get a lot when I was
Yeah,
I gotta put
yeah.
I get turned versus my
Not
dad.
that long.
Really bad.
My dad's
So like, see, my phone takes me like 5 minutes.
I
But I was with my cousin's hair, I live so much.
I couldn't like tell you this, like out of the car.
That's why I hate sunglasses. There was someone standing in the back. Casey, shut up.
That's so
You do
weird.
look
I
like
thought
Will
the
Smith.
same thing about Will Smith. I go, I feel like Will Smith from Men in Black, and you just said it.
You do look like Will Smith.
Yours is wet.
I'm his long lost brother.
I have a worksheet I'm about to hand out. And the worksheet has the first page full of molarity questions, a couple of which we will go through today on the board. And the worksheet has on the other pages a number of review questions that will go over things that we've seen throughout the course of the year. I think this is going to be helpful for you since next chapter, which deals with acids and bases, brings back chemical equations, brings back getting familiar with the names of the chemicals and then how to express the names in formulas. This is probably a skill that has accumulated rust, since it hasn't been something that we've focused on specifically since last semester. Although, I trust that the information is still there in your head somewhere, or if it's not in your head, it's readily accessible in the book. So you'll be able to, you will, my suspicion is you'll have to do some digging. All of this material is probably not at the forefront of your brain. If it is, good for you, like you're a lucky one. And if you're not, that's fine, because you'll have an entire week to do this. So this worksheet is going to be due on Friday, and we'll plan on having our tests next week on Tuesday. So this is, that actually works out well with standardized tests. I think the standardized tests come next week. So, yeah, let me pass this out. That way we have something to look at while I erase the board. I did not assign point values to individual problems, but if I had to guess, just off of the number of problems that are in here and the material, this worksheet is probably going to be in the 100 to 150 point range. So this is pretty significant chunk of work here. And it's going to, as a result, reflect significantly on your grade. Because I'm not sure how many points we have in our chemistry grade to this point, but it's probably not even 150. So this worksheet is going to, consider it a kind gesture for you to, now 3/4 of the way into the year, see an additional review so that future material will be more understandable, and when we see the final, you won't be completely blown away, right? So this is, in some ways, a kindness to bring all this material back to life. A nice thing about the sheet is that each topic is sort of clumped together, so if there is something that you have to address and you dig in the book, you'll be able to likely answer a battery of questions following that, and then you'll be able to move on to the next topic. But yeah, this is a pretty involved sheet. Any questions on the worksheet? Again, I'm not sure what the dates are on that, on those, but chem test next Tuesday and chem worksheet on Friday. From what I saw in the weather report this morning, it looks like we will have school tomorrow from what they're projecting. I know I'm getting a puzzle book from Allie, but their current prediction is that the weather system will not come to Fort Wayne until 9 or 10 o'clock tomorrow. And if it comes at 9 or 10 o'clock tomorrow and it's supposed to start as only rain, we're not gonna, don't expect school to be canceled tomorrow. Now, Curtis Smith this weekend may have made you think that school was gonna be canceled this weekend, but he was just grabbing a lot of hype. Now, between Tuesday, the start of the snow, and Wednesday, the stop of the snow, there's supposed to be 4 inches of accumulation. So, Wednesday, if there is going to be a day this week, expect that would be the day. But don't plan on it for tomorrow. Even though the initial estimates were that it was gonna come, the storm was gonna come between 2 and 4 a.m. tonight.
Boo.
Yeah, right? So,
Wait, is this like a snowstorm?
there's a snowstorm coming, yeah.
It's really bad, like,
Oh.
yeah, it's really bad, and we're like, Fort Wayne's like in the sliver that's supposed to be half rain, temperature drops, then it goes like sleet
This
and
stupid
crap.
groundhog didn't see his shadow, he should be spring already.
I agree. I'm allergic to
Yeah,
it.
yeah, we haven't had
I'm
snow day
so
all
mad
year.
when I was on my siblings.
Oh my god.
Have we had a snow day?
No, we have not had snow day. We need a snow day.
This is
We need a snow day. Official snow day.
Wednesday.
It's a
Put it on the record, it'll be Wednesday.
Like for officially.
Like, probably not.
It's like
Our best chance of the year
I
is
mean,
Wednesday.
people could be getting excited about it.
Yeah, and yes, people are getting excited about it, yes.
I wasn't getting excited about it, I didn't know about it.
Uh,
Is it from like the carryover from, I know that like, Kansas City had like some sort of like, ice storm.
It's something, yeah.
Or the adjudicator was telling me.
God.
Yeah, it could be the same storm.
I don't know.
Okay, let's, you can worry about that later, guys. So let's get to a couple molarity questions. remind me what molarity is. There are two answers here, possibly. Concentration, okay, so molarity is a measure of solution concentration. And molarity measures moles of solute, those are the things that you're dissolving in your solvent, over liters of solution. Now, I will tell you, if in any molarity problem you start with the molarity equation, that's going to give you a good basis for attacking the problem. Let me come up with an example that will be similar to what you'll see on your sheet. A periodic table will be helpful for this, so when I say will be helpful for this, it'll be helpful for what we do today, it'll be helpful for what we do, everything you do on the worksheet, having a periodic table will be quite helpful. If you have misplaced your paper copy, there's always a copy in the back of your book. Open the inside back cover, you can grab a table that way. So let's ask this question. Compute the molarity of a 250 milliliter solution made with 75 grams of aluminum carbonate as a solute. So you got 75 grams of aluminum carbonate that you dropped into 250 milliliters of solution. We want to find the molarity. Like I said, it's not a bad idea to say, well, if I need to compute the molarity, let's remember what we need. We need moles of solute over liters of solution. Well, we don't have either of these things directly. Did they tell us how many liters were in the solution? Not directly. Did they tell us how many moles of solute we had? Not directly, but we can figure out both. Anybody have an idea as to how we can do either of those? Offer it and we'll attack.
What's the two in like 250 milliliters of solution, like this liter type solution?
So take the 250 milliliters and, like Holly said, substitute it in as liters. So how are we going to do that? What's our conversion from milliliters to liters? How many milliliters are there in a liter? 1,000, yeah? So 250 milliliters is just 0.25 liters. Maybe you could have seen that like fractionally, depending on how acute you are with your fractions. You may have been able to see. So 0.25 liters. Now all we need is the numerator. The numerator is asking for moles of solute. Yeah? Convert the 75 grams to moles. Now, when I say aluminum carbonate, oh boy, right? We gotta put this together. We gotta make this compound. So, when you see carbonate, does that make you think of anything? Carbon, okay, good. Okay, what else when you see carbonate? Has anybody gotten rusty?
CO something?
CO something? Yeah, I believe it was CO3, and it had a charge. Does anybody remember?
Negative, 2 negative.
2 negative, okay, good. CO3, 2 negative. Okay, so that's an ion at the very least. So we have an ionic compound. Let's go to aluminum. He's going to be on the periodic table. What kind of ion is he going to form? Look at his location on the table. Positive 3. Because when you look at aluminum, aluminum's in the third column. And the third column would have 3 valence electrons and would prefer to lose those 3 valence electrons. If you look at aluminum and its dot structure, it would be like that. So he's gonna prefer to lose 3 electrons. And be that guy. Now put those two things together in an arrangement that makes a balanced molecule. How are you gonna pull that off? With the 3 plus and the 2 minus. How are you gonna balance that out? Who said that? Allie, what'd you say?
AL2 and 2 of the CO3s.
Al2 and then 2 of the CO3s?
Yeah. 3 of the CO3s.
3 of the CO3s. That will give you 6 positive charges and 6 negative charges balancing out to be 0. So now we know what our substance is. Now we can go to the periodic table to see how much 1 mole would weigh. So let's go to the periodic table. We've got 2 aluminums. How many carbons do we have? 3. And how many oxygens? Is it 6 or 9?
9.
Which is it?
9.
And why is it 9?
There's
Yes. We have 3 carbonates, right? Imagine this molecule. No, this is good that we're rethinking this. I mean, if you're looking at the crystal structure of this molecule, it's something like this. You've got the positive ions and the negative ions. You've got 2 aluminum ions for every 3 carbonate ions. And each carbonate ion has 3 oxygens. So in total, you have 9 oxygens. So let's use the periodic table to come up with the mass. 2 aluminums is going to be 2 27.0s, or 26.98s, let's say that. 3 carbons is going to be 3 12.01s, and 9 oxygens is going to be 9 16.00s. And all of those things then can be added together to find what the mass of 1 mole of aluminum carbonate is. Okay, so 2 26.98s is 53.96, that's the mass of aluminum's contribution. 3 12.01s makes 36.03. That's the carbon contribution. And 9 times 16 is 144. That's the oxygen contribution. Add it all up. That's going to give you the mass of the entire molecule, or rather the mass of 1 mole of that molecule. You get 233.99 grams per mole. I'll take the liberty of rounding that to 234, just for simplicity. 0.99 seems mighty close to 234. So right off the bat, you can see that we don't have a full mole of aluminum carbonate. We actually have significantly less than a mole. Like Holly said, we need to convert our grams to moles. So 75 grams is the number of grams of aluminum carbonate that we have. And we have to then use our information about grams per mole. 234 grams makes 1 mole. And then run those numbers, 75 divided by 234, 0.32 moles. And in specific, that's moles of aluminum carbonate. I'll be kind to you. I'm going to flip back into the book and find a page where the polyatomic ions are listed, in the event that you have forgotten them. page 148. So in case those are rusty, that's the page to access those. Now, we haven't finished the problem. We know we have 0.32 moles of solute. We know we have 0.25 liters of solution. If we just divide those numbers, we'll have our molarity. So take 0.32 divided by 0.25, and you'll end up with 1.28, capital M for molar solution. 1.28 molar. Here's your answer. So we weren't given moles of solute directly, we weren't given liters of solution directly, but we were able to figure out both by converting the milliliters to liters by way of the basic one-step calculation, and then the grams to moles by using the periodic table. Keeping in mind that aluminum carbonate is an ionic compound, we gotta come up with this formula first. Questions on this? Good. Okay. Let me give you another example. Explain how you would make a 0.25 molar solution of sodium chloride from let's say 50 milliliters of a 10 molar solution. You want to make a 0.25 molar solution. You have a 10 molar solution. Think about this. What you've got is 50 milliliters of a 10 molar solution. And what you want is a 0.25 molar solution. Look at the two concentrations there. One of them is significantly more concentrated than the other. So if you're starting with this guy here, you'd be able to make the other guy by just diluting it. Think about it. If we just start pouring in water, we could pour in enough water to dilute the solution to 0.25 molar. The question becomes, how much water do we have to dilute it with? Because right now we have a solution that's too concentrated. So let's look at this. I'm going to look at this as two scenarios. What we have and what we want. Now we want to take the concentrated solution and use it to make the diluted solution. So let's look at what we have first. We have the 10 molar solution, 50 milliliters of it. Now I think if we use the molarity equation, when in doubt in a molarity problem, write the molarity equation. We can start filling in information that we know. Look at this situation of what we have. Do we know the molarity of the solution? Yes, the molarity is 10. Do we know how many moles of solute there are? No. Do we know how many liters of solution there are? Yes. 50 milliliters 1,000 milliliters is 1 liter. That comes out to be 0.05 liters. That's a situation that could be solved out. If you just cross multiply here, moles of solute equals 0.5 moles. I'll just leave it at 0.5. Moles of solute is 0.5. When you do the multiplication, 10 times 0.05 is 0.5. Multiply any number by 10, it just hops the decimal one to the right. So we know exactly how many moles of our solute we have. That's how many moles of sodium chloride we have. And what do we want? We want to use those moles of solute to make a solution of this concentration. So let's set up the problem here. Molarity equals moles of solute over liters of solution. Do we know the molarity of the solution that we want? Yes, the molarity that we want is 0.25. Do we know how many moles of solute we have? Yes, because how are we going to make the solution? We're going to make the solution by pouring in more water. What we're not going to do is alter the salt. We were given a certain amount of salt. What we wanted to do was dilute the solution using that salt. That's what we want. We want to take this salt and use it in our solution. So this 0.5 was our salt that we want to use in our new situation. So the 0.5 moles is how much solute we have. Do we know how many liters are in this solution? No, that's what we don't know. If you look at the situation you have two of the pieces of information to solve for the third. If you use the information that you solved for, now you have two pieces of information to solve for the third. This can be solved out. So if you cross multiply, you get 0.25 L, L for liters of solution, equals 0.5. Thus L is 0.5 divided by 0.25. Thus L is 2. That's the number of liters of solution that we need. Does that answer the question? No, the question is how would you make this solution? So if initially you have a 10 molar solution, very concentrated, and only 50 milliliters of it. And what we now found out is if you use that much salt to make a 0.25 molar solution, you're going to need 2 liters. So how are you going to do this? How are you going to get from here to there? If here you need 2 liters of solution, how are you going to get from 50 milliliters to 2 liters? Yeah.
Add 195 milliliters of water.
I hope not that much. 100, did you say 195 milliliters?
Yes, 1.95 liters.
1.95 liters. Okay, let's watch the liter math here. Initially, we had 0.05 liters, right? That was our initial amount. Then we're going to have to add some amount of water to make 2.00 liters. Because this is what we have, and this is what we want. And like Allie noticed, 1.95 liters is the magic number that makes that true. Now that's actually 1,950 milliliters. So 0.05 plus 1.95 makes 2.0. So how do we do it? We've got to add extra water. How much extra water do we have to add? Not 2 liters of water. If we added 2 liters of water, we'd actually be over the amount of water that we need because we were up to 50 milliliters to begin with. So how are we going to do this? We're going to add 1.95 liters of water. That's going to dilute the solution down to the point where we have the proper molar concentration. Hey, that could have been time better. So that should give you at least one problem to guide you through all of the problems that you see on the first page. And everything beyond the first page is things that you've seen before, Some may be at the tip of your mind and others may not, so be prepared.